Space is not far away. That sounds wrong. Every book, every documentary, every classroom lesson tells us the opposite. Space is distance, millions of miles, billions of light years, endless separation. But here is the twist that changes everything. Distance in space may not be real in the way you think it is. Not solid, not fixed, not even absolute. The idea that the universe is a giant empty box with objects scattered far apart is slowly collapsing under modern physics. And once you see why, you cannot unsee it, because the truth is deeper, stranger, and far more beautiful than the simple word far allows. In this video, you are going to learn why distance depends on motion, why time itself stretches, why 2 points in space are not as separate as they look, and why the universe may not be spread out at all. You will discover how the equations of Albert Einstein shattered the old idea of fixed space, how data from NASA confirmed that space itself expands, and why images from the Hubble Space Telescope quietly revealed that galaxies are not simply flying away through emptiness, but are being carried apart by the stretching of space itself. That detail alone changes the meaning of distance, because if space stretches, then distance stretches, and if distance stretches, then it is not a stable ruler. It becomes flexible, it becomes dynamic, it becomes something that depends on deeper laws. We will also break down a fact that most people never hear clearly explained. Some galaxies are now farther away than the age of the universe seems to allow. The universe is about 13.8 billion years old, yet there are objects whose current distance is far greater than 13.8 billion light years. That sounds impossible. Nothing can move faster than light. So how did they get there? The answer is not faster travel. The answer is that the space between us and them expanded. This means distance is not about motion through space. It is about the behavior of space itself. And once that idea sinks in, the word far starts to lose its meaning. Then we go deeper. We will talk about how when you look at a star, you are not seeing where it is. You are seeing where it was. Light takes time to travel. So every distance you measure in space is also a measurement of time. Distance and time are tied together. You cannot separate them. This is not philosophy. This is physics. According to relativity, time moves differently depending on speed and gravity. That means distance also shifts depending on those conditions. Two observers moving differently will not even agree on how far apart two events are. So which one is correct? The answer is both. Distance depends on the observer. That alone destroys the simple idea of a universal ruler stretching across the cosmos. And then comes the deepest layer. At the quantum level, particles can become connected in a way that ignores classical separation. Experiments have confirmed that entangled particles affect each other instantly across vast distances. The effect does not travel through space in the normal way. It simply appears correlated. Even Albert Einstein once called it spooky action at a distance, yet experiments have continued to confirm it. This does not mean information travels faster than light in a simple sense, but it does suggest that separation at the smallest level may not behave the way we expect. The universe might not be built from isolated points scattered across emptiness. It might be a connected structure where distance is more about perspective than about true separation. And that leads to a powerful realization. The feeling that space is vast and empty may come from how our brains evolved, not from how reality truly works. Our senses were built for survival on Earth. We measure steps, we measure fields, we measure roads. That logic does not scale cleanly to cosmic reality. The universe does not owe us intuitive answers. It follows mathematical rules that often break common sense. By the end of this video, you will understand why distance can expand without objects moving, why time and space cannot be separated, why looking deep into space is looking back into time, and why modern physics suggests that the universe may be less like scattered islands and more like a single fabric. You will see why far away might simply mean connected through a structure we do not fully understand yet. And once you see this clearly, the night sky will never look the same again. Stars will no longer feel like distant dots in darkness. They will feel like parts of a dynamic system that bends, stretches, and evolves. That is why you need to watch until the very end. Because the final perspective will tie everything together and leave you with a new way of thinking about reality itself. If you are curious about the universe, if you want to understand the ideas that are reshaping physics, and if you enjoy exploring concepts that challenge everyday thinking, you are in the right place. Welcome to our channel, where we break down complex cosmic ideas into simple, clear explanations that anyone can follow. Subscribe now and join us as we explore the universe, one mind-bending truth at a time. Distance feels simple on Earth. You walk from your house to the store. You count the steps. You drive across a city. You read the number on a sign. 5 kilometers, 10 miles, a straight road between 2 points. We grow up trusting rulers, maps, and GPS signals. A meter is always a meter. A mile is always a mile. If 2 buildings are 1 kilometer apart today, they will be 1 kilometer apart tomorrow. Distance feels fixed, solid, objective. It feels like one of the most basic facts about reality. No debate, no mystery, just space between things. Even a child understands it. You stretch a tape measure from one wall to another. The number does not change because of who you are or how fast you move. That is the common sense view. That is the foundation we carry into everything else. Then we lift our eyes to the sky, and we use the same logic. We simply scale it up. Instead of kilometers, we use light years. A light year sounds complex, but it is still just distance. It is how far light travels in 1 year. Light moves at about 300,000 kilometers per second. So in 1 year, it covers almost 9.5 trillion kilometers. That number feels solid, scientific, exact. So when we hear that a star is 100 light years away, we think we understand what that means. It sounds like a longer road, a bigger gap. When astronomers say a galaxy is 2 million light years away, or 10 billion light years away, it sounds like the same idea, just larger, more space, more separation. The words feel stable. They feel like facts carved into stone. A star is there. We are here. Between us is a huge empty stretch, case closed, but physics tells a very different story. Space is not a container holding objects inside it. It is not an empty box where stars float like dust in sunlight. That picture is comfortable, but it is wrong. In the early 20th century, Albert Einstein changed the foundation of reality with general relativity. He showed that space and time are not separate things. They form one fabric called space-time. This fabric is not rigid. It bends around mass. It curves around planets and stars. It can stretch. It can ripple. Gravity is not a force pulling objects across empty space. It is the shape of space-time itself. When Earth moves around the sun, it is not being pulled by an invisible rope. It is following a curve in space-time. That means space is active. It is dynamic. It reacts. It changes. If space can bend, then the distance between 2 points depends on how that fabric is shaped. If space can stretch, then the ruler itself can stretch. If space can move, then separation is not fixed. Distance depends on how space behaves. This is the key shift. We are not measuring empty nothing. We are measuring a living geometry. And if space can stretch, what happens to distance? Observations in the 20th century began to answer that question. Telescopes revealed that distant galaxies show a redshift in their light. Their light waves are stretched toward the red end of the spectrum. Data collected and analyzed by researchers, including major contributions from NASA and detailed measurements from the Hubble Space Telescope, confirmed a shocking result. Galaxies are moving away from us, not just a few, almost all of them. The farther away a galaxy is, the faster it appears to recede. At first, it sounds like a giant explosion, like debris flying outward. But that picture is incomplete. The galaxies are not simply traveling through pre-existing empty space. The space between galaxies is expanding. The fabric itself is stretching. Imagine dots on the surface of a balloon. As the balloon inflates, each dot moves away from the others, not because the dots are crawling across the surface, but because the surface itself grows. In the same way, cosmic expansion means the distance between galaxies increases because space-time expands. This leads to a strange fact. The universe is about 13.8 billion years old, yet some galaxies are now more than 30 billion light-years away in terms of present distance. That number sounds impossible. Nothing can move faster than light through space. So how can something end up farther away than light could travel in the age of the universe? The answer is that space itself expanded while the light was traveling. The galaxy did not outrun light in a simple race. The track itself grew longer. How can something travel farther than time allows? That tension shows us that distance in cosmology is not a simple measurement of motion. It is tied to the changing geometry of space-time. Then there is another layer that quietly breaks our intuition. We never see objects as they are right now. We see them as they were. Light takes time to travel. The moon is about 1 light second away. You see it as it was 1 second ago. The sun is about 8 light minutes away. You see it as it was 8 minutes ago. The nearest star beyond the sun is about 4 light years away. You see it as it was 4 years ago. When you look at a distant galaxy that is 10 billion light years away, you are seeing light that began its journey 10 billion years ago. Distance in space is also time in the past. You cannot separate them. Every cosmic measurement of distance is a measurement of how long light traveled, and time, according to relativity, is not absolute. It flows differently depending on gravity and speed. Clocks tick slower near strong gravity. Clocks tick slower when moving close to the speed of light. Two observers in different conditions will disagree on how much time has passed between events. If time changes depending on motion and gravity, and distance is measured using light and time, then distance also depends on motion and gravity. Two observers moving differently may not agree on the separation between two distant events. That means distance is not a universal constant written into the background. It is woven into space-time and depends on perspective. If time changes and distance depends on time, then distance changes too. At the quantum level, the challenge grows even deeper. In the strange world of quantum physics, particles can become entangled. When two particles interact in certain ways, their properties become linked. Measure one, and you instantly know something about the other, even if it is very far away. Experiments have tested this many times. The results match quantum theory. The correlation appears without any visible signal traveling between them, in the classical sense. No delay that matches a particle crossing space. The connection is built into the shared quantum state. Even Albert Einstein questioned this idea, yet repeated experiments continue to support it. This does not allow faster-than-light messaging in a simple way, but it does challenge the idea that two particles separated by huge distances are fully independent. At the deepest level, separation may not behave as a solid wall. It may be a feature of how we describe systems at large scales. The universe may not be spread out in disconnected pieces. It may be described by deeper relationships that ignore classical distance. The universe may not be spread out. It may be connected. All of this clashes with the way our brains are built. Human perception evolved to handle forests, rivers, mountains, and small social groups. We think in maps and paths. We draw lines between cities. We assume straight roads and flat surfaces. That works well on Earth. It keeps us alive. But the cosmos is not obligated to match that mental model. When we picture space as a giant dark box with objects scattered inside it, we are projecting a human image onto a reality that is far more complex. Space-time can curve, it can expand, it can link events in ways that ignore simple separation. The word far might reflect how our minds organize experience, not how the universe truly operates. The more physics advances, the more it shows that distance is not a basic ingredient. It emerges from geometry, motion, gravity, light, and quantum relationships. The ruler bends with the fabric. The clock stretches with speed, the map shifts with expansion, and slowly, the simple idea we trusted begins to dissolve. Space is not far away. Distance depends on space stretching. It depends on time bending. It depends on the delay of light reaching our eyes. It even depends on deep quantum connections that ignore the idea of separation. When space expands, the gap grows without anything racing through it. When gravity curves space-time, rulers no longer stay straight. When time slows down at high speed or near massive objects, measurements shift. When we look at distant galaxies, we are not seeing where they are now, but where they were billions of years ago. And when particles connect across vast regions through quantum entanglement, separation starts to lose its meaning. All of this points to one powerful shift. Distance is not a simple empty gap between two objects. It is a result of how space-time behaves. It is shaped by motion. It is shaped by gravity. It is shaped by light. It is shaped by the deep structure of reality itself. So what is far? Far may not mean separated by a fixed stretch of emptiness. It may simply mean that we are measuring reality with tools that only capture part of the picture. It may mean that our understanding is still growing. The word distance might describe our limits more than it describes the universe. The deeper physics goes, the more it suggests that what looks spread out could be part of one connected system, galaxies drifting apart, time flowing at different rates, light carrying the past into the present, particles linked across cosmic scales. These are not random facts. They are clues, clues that the universe is not a cold collection of isolated pieces, but a dynamic fabric, a structure that bends, stretches, and connects everything within it. And if that is true, then the night sky is not a map of distant islands. It is a pattern woven into one continuous whole. Maybe the universe is not separated by distance. Maybe it is one single fabric we are learning to see. If this perspective changed the way you think about space, take a moment to like this video so more people can explore these ideas. Share it with someone who looks at the stars and wonders what they really are. And subscribe to the channel to join us as we continue breaking down the biggest mysteries of the cosmos in simple, clear language. The next discovery might change everything again.